So a lot of stuff to read here. So 13.2 is applications in business and economics. So we start with the consumer surplus. Well, information about consumer and producer surplus. So let P equal D of X be the price demand equation for a product, where X is the number of units of the product that consumers will purchase at a price of P per unit. Suppose that P bar is the current price and X bar is the number of units that can be sold at that price. If the price is higher than P bar, the demand X is less than X bar. But some consumers are still willing to pay the higher price. Consumers who are willing to pay more than P bar, but who are still able to buy the product at P bar have saved money. We want to determine the total amount saved by all consumers who are willing to pay a price higher than P bar for the product. We do this by using the consumer surplus integral. Yeah, so consumer surplus is, what is it? Let's say one store, you're going to buy a TV and one store has a TV for 1,000, but the other store has a TV for, let's say, 900. And you have the money to buy it for 1,000, and maybe you're not willing to drive the miles to go get it for 900. So this is where consumer surplus is. It's like you have the money to buy it for 900. Oh, actually, you have the money to buy it for 1,000, and you're not willing to go pay 900 for it because you don't want to move to another place. So this consumer surplus is how much money could you save, even if you're willing to pay that price of 1,000. So this is the consumer surplus. Okay. So if X bar P bar is a point on the graph of the price demand equation, P equals DX, for a particular product, then the consumer surplus CS at a price level if P bar is given by the integral, CS equals the integral from 0 to X bar of D of X minus P bar with respect to X. This is the area between P bar and D of X from X equals 0 to X bar. So this is the area. Everything in here is the area that we're finding. So that's the consumer surplus. So the consumer surplus represents the total savings to consumers who are willing to pay more than P bar for the product, but are still able to buy the product for the current price, P bar. All right. Oops. So let's get going. So example 1. Find the consumer surplus at a price level of P bar equal to 8 for the price demand equation, P equals D of X equals 20 minus 0.05X. First step is to find the value of X bar. We need that value in order to set up our integral, because our integral goes from 0 to X bar. And the way to solve for X bar is to take our D of X function and set it equal to P bar. So we let P bar equal to D of X, and this is going to give us X bar. So that's our first step. So let's go ahead and set that up. All right, number 1. Okay. So step 1. We let P bar equal to D of X, which means P bar, which is the current price, is 8. And we set it equal to D of X, which is going to be, D of X bar, which is going to be 20 minus 0.05X bar. Okay. And now all we have to do is solve for X bar. So we're going to move this 20 over by subtracting it, and we'll get negative 12 equals negative 0.05X bar. And then we'll divide by negative 0.05, negative 0.05, and we are going to get 12 over 0.05, we are going to get, 240 equals x bar. Okay, so we want to state the answer as a point x bar comma p bar. So that's our last step here. We're going to say that the point is 240 comma 8. Okay, so step 1 is done. We have found the value of x bar, which means we can actually set up that integral. But first, we are going to sketch a graph of d of x. So step 2, sketch d of x. If d of x is 20 minus 0.05x, let's go ahead and make an xy chart. All right. Okay, and if we're thinking in business terms, we're not going to choose anything negative. Let's go ahead and start at 0. And since my x bar value is 240, let's just go by 100s. So we're going to have 0, 100, 200. Why not put 240 in there? And then 300, and we could probably stop at 400. Okay, and we're going to plug all these numbers in for x. So that means we could use Desmos. So let's see, hide that. Okay, move that over. Let's go ahead and make this XY chart. Whoops, wrong keyboard. Okay, 20 minus 0.05x. And then I'm going to hit the table button and type in those values. 0, 100, 240, oh, missed 200. 200, 240, 300, and 400. And look at that, we get a 0. So my XY chart is 20, 15, 10, 8, 5, and 0. Okay. And then we label my x-axis appropriately. We went by hundreds. So we'll have 0, and I think I can space this out. 100, 200, 300, and 400. And then we go up to 20. So I can say 5, 10, 15, 20. Okay, and let's draw d of x. At 0, we're at 20. 100, we're at 15. 240, we are at 8. Actually, sorry, I keep skipping 200. 200, we're at 10. 240, which I'll just put it right here, we're at 8. So a little bit below. Let's see. So I'll just put it right about here. And then 300, we're at 5. 400, we're at 0. Okay, I think I should have skipped on the other one. Oh, well, it's not perfect, but it's going to look like this. There we go. Good as I can get it. Okay, so there's d of x. And what we're going to do next is draw the consumer surplus area that we're finding. And that's going to be based on the point that we have here. This is our 240 and 8. So and this is the area that we are going to find by using the integral for consumer surplus. So this is our CS. Okay, cool. Now, let's go ahead and set up that integral. So that's going to be step 3. Zoom right there, that's perfect. And then 3, we'll set up consumer surplus, and we're going to get the integral from 0 to x bar. And we found that x bar was 240 of d of x, which is 20 minus 0.05x minus p bar, which is 8. Close that, and that's with respect to x. Okay, clean it up. And we get the integral from 0 to 240. And we can put the 20 and the 8 together. So we'll end up with 12 minus 0.05x dx. And that's what we're going to type in. So over here, stop it. There we go. Integral from 0 to 240. And parentheses, 12 minus 0.05x. Come on, computer. 12 minus 0.05x dx. And we get $1,440. So this number represents the total amount of money the consumers will save if they have the money to buy it without, I guess you could say, a discount. So if they have the money to buy it at a higher price, but they'll buy it for the discounted price. So this is what consumers will save, is $1,440. Okay, that is consumer surplus. Any questions on that?
So on the graph, what's shaded in green, that's the savings right there?
Exactly.
Okay.
At 240 and 8, is it just a matter of drawing the straight lines up and down, or
Like, are you
is there
saying
something
where
else?
did we get that from, or?
No, I get that part, but
Mhm.
though then how it goes straight across and the pink lines you drew from those points.
Yeah. So by looking at the example above, right? So if we just match those two, what we're finding is the area above that point.
Oh, okay.
Yeah, so those are just the dashed lines to show what area we're finding. So those are showing the exact coordinate of x bar, p bar, and that we're finding the area above that point.
Okay, the area above. Got it.
Yeah. Okay. So that's consumer surplus. And now we'll get into producer surplus. Okay. If P equals S of X is the price supply equation for a product, P bar is the current price and X bar is the current supply, then some suppliers are still willing to supply some units at a lower price than P bar. The additional money that these suppliers gain from the higher price is called the producer surplus, PS, and can be expressed in terms of a definite integral. Okay. So definition of producer surplus: if X bar, P bar is a point on the graph with a price supply equation, P equals S of X, then the producer surplus PS at a price level of P bar is given by PS equals the integral from 0 to X bar of P bar minus S of X dx, and which is the area between P bar and S of X from X equals 0 to X bar. The producer surplus represents the total gain to producers who are willing to supply units at a lower price than P bar, but are still able to supply units at P bar. So I guess you can consider this, I mean, we could just say our Walmart and HEB, right? So some producers may give HEB a certain item at a higher cost, let's say, than Walmart, or the other way around. Some producers may give Walmart an item at a higher cost than they give it to HEB. But no matter what, they're still going to make money on it because they have their item at a store for a higher price, which is going to make them money. And then they have an item at another store at a lower price. So that's producer surplus. And kind of makes sense if I guess you compare it at shopping markets. Like this is more expensive here and it's cheaper over there. So, but either way, the producer's still going to make money. Okay. So example 2, find the producer surplus at a price level of P bar equals 62 for the price supply equation P equals S of X equals 15 plus 0.1X plus 0.0003X squared. And just like the last one, we're going to find X bar. So we're going to set P bar equal to S of X bar. All right. So let's go ahead and set that up. So number 1, all right. So number 1, we let P bar, that's not a P, P bar equal S of X bar. And P bar is 62. And S of X bar is 15 plus 0.1 X bar plus 0.0003. I hate this notation right here. X bar squared. Looks like X to the -2, right? All right. Okay. So we set those equal to each other. What we're going to do is move 62 over. So you're going to subtract it. It's only going to combine with the 15. So I guess I could write that in here. We'll say minus 62 minus 62. And I'm going to rewrite everything. So you have 0 on the left side. And the way I'm going to rewrite the right side is with highest power first. So 0.0003 X bar squared plus 0.1 X bar, and then 15 minus 62, was that -47? There we go. Okay. And what we have is now a quadratic equation, which can be solved either by factoring, completing the square, or a quadratic formula, or can be solved by using Desmos. What do you guys want to see, Desmos or the quadratic formula?
Desmos.
Yeah, for sure, right? 0.003. Oh, one more 0, right? 0, yep, 3. And you're just going to type in regular old X. There's no X bar on here. So X squared plus 0.1 X minus 47. Okay, now let's go ahead and look at this graph. What are my intervals? If P bar is 62, oh yeah, we might have to zoom out really big. Let me see. What does this graph look like? Oh, it's a parabola, of course. Okay. So what we want to do is here you have, let's see, we're looking for when it's 62. And if you quadratic, no, it might not be. Actually, yeah, we can solve this. Watch this. So we're going to go to our table. And this time, we know that when P bar is 62, we're looking for X. So we don't even need the graph right now. We're just going to go and type over here. Can I type in there? Let me see. If not, we're going to have to quadratic formula this. Sorry, guys. Let me type in there. It's not going to be able to find that. Let me see. That's good. And then that. Nope. All right. Well, never mind. Desmo's not for the win. Quadratic formula it is. I thought you could type Y values in here. I guess not. Boo. All right. Either way. Okay. So quadratic formula and then Desmos will help out. Okay. Here we go. So for our quadratic formula, label everything A, B, C. So A is 0.0003, B is 0.1, and C is -47. So now we put this into the quadratic formula. We're going to say X bar is equal to -B. So -0.1 plus or minus the square root of B squared minus 4 times A, which is 0.003, times C, which is -47, all over 2 times A, which is 0.0003. Okay, here we go. X bar equals -0.1 plus or minus. Okay, and now I'm going to take care of the square root in Desmos. That's where it can help us out here. So we're going to say square root of 0.1 squared minus 4 times 0.0003 times -47. And then that's going to give us, I'll just round it to 0.26 over 2 times 0.3, which is 0.0006. Okay. And now just a little more cleanup. We're going to have 2 answers here. We're going to have, for the plus route, -0.1 plus 0.26 over 0.0006. So let's figure out what that one is. -0.1 plus 0.26 over 0.0006. And we get 266.67. Which we'll just make into 267. Okay. And then we'll go the minus route. And we'll have -0.1 minus 0.26 over 0.006. And here you'll have, I don't know why that keyboard keeps popping up. I'll fix it later after here. -0.1. Let me actually make this a fraction first. There we go. -0.1 minus 0.26 over 0.0006. And that gives us -600, which is out because here we're talking about demand and we can't have negative demand. All right. Had to go old school on that one, guys. Sorry. Desmos did not want me to type in those Y values. I thought you could. I've done it before. It's just not doing it now. Okay, which means to finish up number one, we found the point, and this is going to be our X bar P bar point. So this becomes 267 and 62. There we go. Okay. And now we're going to graph it. So we'll make an XY chart. So there's step 2. I can fit that. Yeah, I have to fit that over here. All right. 2. We have P of, not P of X. S of X equals 15 plus 0.1x plus 0.0003x squared. Make my XY chart. And I have Desmos up already for that function. No, that's not for that one. That's for the new one. So I'm going to type this in all over again. 15 plus 0.1x plus 0.0003x squared. And then I'll use my table feature. And let's start at 0. And if my X bar value is 267, then let's go by hundreds again. 0, 100, 200, 300, 400, 500. Why not? We can stop there. Doesn't have to be perfect. 0, 100, 200. I'll put in my X bar value of 267, 300, 400, and 500. Okay, so 15, 28, 47, 72, 103. Oh, I messed up. That's 267 and 62. There we go. 72, 103, 140. Okay. Now let's draw out this x-axis. 0, 100, 200, 300. 400 and 500. And then my y values, which are right there. 15, 28, 47, 103. Let's go by 20s. Sure. I don't know if we should skip. Probably not. 20, 40, 60, 80, 100, 120. We stop at 140. Okay. We are ready to graph. And producer surplus. 0 and 15. I'll put around there. 128. I'll put around here. 247, just a little above 40. 300, 267. Oh, we'll draw that in later. 372, I'll put around here. 400 and 103. Just put that right on 100, sure. And then 500 and 140 right there. So here's what producer surplus looks like. And now let's draw in that point, X bar, P bar, which is at 267. So we'll put it around here. Why not? 267 and 62. Okay, and this is the area we are looking for. Here is our producer surplus. Now, on to the integral. Producer surplus on the integral from 0 to 267 of P bar, which is 62, minus S of X, make sure to put it in parentheses, 15 plus 0.1x plus 0.0003x squared dx. And then we can distribute that negative. You get 0 to 267 of 62 minus 15 minus 0.1x minus 0.0003x squared dx. And let's just type that in. So let's see. Over here, I get the integral from 0 to 267 of 62 minus 15 minus 0.1x minus 0.0003x squared. Close that. And with respect to x, we get that the producers will gain $7,081.13. There we go. So no matter if they supply units at a lower price, the store that has the units at a higher price, they'll still make a gain, and this gain will be $7,081. Okay. Any questions on that? Sucks we gotta
So,
use the
quick
quadratic
question, man.
formula, but what's up?
When you want us for the show work, whenever we do the assignment, is there a certain part that you want us to show, or do we show all of that?
Basically whatever I'm writing down right now is, I guess I could say what should be on your paper.
Damn.
Because I don't know how else you wouldn't show work trying to get that X bar value.
I'm good at mental math.
You good at all calculating all those decimals in your head?
Definitely.
Just show as much work as you can. I mean, we had to go old school with the quadratic formula, but yeah. Maybe I'll figure it out at the end. Like I said, let's move on for time's sake. I know you can type Y values in. I just forgot how to. Okay, last page. All right. In a free competitive market, the price of a product is determined by the relationship between supply and demand. If P equals D of X and P equals S of X are the price demand and price supply equations, respectively, for a product, and if X bar P bar is the point of intersection of these equations, then P bar is called the equilibrium price, X bar is called the equilibrium quantity. If the price stabilizes at the equilibrium price P bar, then this is the price level that would determine both the consumer surplus and producer surplus. All right, so for this problem, we're looking for equilibrium. So 3, find the equilibrium price and then find the consumer surplus and producer surplus at the equilibrium price level. If P equals D of X equals 39.0.05x and P equals S of X equals 15 plus 0.05x. 1, find the equilibrium quantity and equilibrium price. Okay, so to do this, the first thing we're going to do is take D of X and set it equal to S of X and solve for X. Whatever we come out with will be considered X bar, and this will also be considered the equilibrium quantity. So that's going to be our first step. So let's go ahead and do that. I guess we'll call that 1A. Why not? 1A. All right. So we are going to set d of x equal to s of x, just like it says. Okay, so d of x is 39 minus 0.05x equal to s of x, which is 15 plus 0.05x. And all we have to do now is solve for x. So we'll move 15 over. And in the same move, we'll add 0.05x over to the right side. (39 minus 15), that is 24, equal to 5 cents plus 5 cents, 10 cents x. Okay. Divide by 0.10, and that should give us 240 equals x. But now this is going to be considered x bar. So we have now found the equilibrium quantity. This is the EQ. Okay. So now the next step to find the equilibrium price, well, since both functions intersect each other at this point x bar, p bar, if two functions intersect, this means that they are equal. So in order to find p bar, all we have to do is take 240 and plug it into d of x or s of x. It doesn't matter because we're going to get the same exact value, and that'll give us p bar. So that's step 2. So we'll say 1b. We'll say find p bar. So I'm just going to take 240 and plug it into d of x. So we're going to say d. I'll say find p bar when x is 240. So we'll say d of 240 is going to give me 39 minus 0.05 times 240. All right. And then we'll get 39 minus 0.05 times 240. And we will get 27. This is p bar. Okay, and just to show you that you'll get the same exact value, since I have decimals up, I'll plug it into s of x, which is 15 plus 0.05 times 240. Oops. And you see, we still get 27. And the reason for this again is because both functions intersect, which means they are equal at this exact point. And step C says state our answer as the equilibrium point. So our equilibrium point is going to be 240, 27. There's our x bar, p bar. All right, not bad. Okay, and then step 2 says sketch a graph of s of x and dx. All right. Well, let me see. Yeah, let's do our XY charts. Okay. So 3. Zoom in, save room. So if d of x is 39 minus 0.05x, and here's my XY chart. Well, we're going to do the same like we've done for all of them. Since this is a business model, we're going to start at 0, no negative numbers. And we're going to go up 100, 200, our X bar value was 240. Throw that in there. And I'll go 300, 400. Shouldn't need more than that. All right, now Desmos. Let's type this function in. 39 minus 0.05x. Let me do my chart, and I need to get rid of that keyboard. 0, 100, 200, 240, 300, and 400. There we go. So 39, 34, 29, 27, 24, and 19. So there's the XY chart for D of X. Now we need an XY chart for S of X. And S of X is 15 plus 0.05x. And then same exact values here. 0, 100, 200, 240, 300, and 400. Okay, so now you type that function in here now. And we're gonna get 15 plus 0.05x chart. Oh my goodness. Don't, it's almost over. 0, 100, 200, 240, 300, and 400. And we get 15, 20, 25, 27, 30, and 35. Okay, that's enough information we need, so we can go ahead and sketch this graph. Let me make my X values accordingly. So 0, 100, 200, 300, 400. My Y values, I have 15, 20, 25, 30, 35, 39, 40, 29. Again, this is just a sketch, so I'll go by 5s. No skipping. Five, 10, 15, 20, 25, 30, 35. That's the highest I go. Okay, so now let's go ahead and graph D of X, which I put in red. And 0 and 39, oh, actually went up to 40. So that's gonna be up here. And then 134, right below 35. And then 229, right below 30. 240 and 27. We'll draw that point in last. 324, right there. And then 419. There we go. So here is D of X. And now let's draw S of X. 0 and 15, 120, 225, 330, and then 435. There's S of X. And then, of course, right where they intersect, that's our point of 240 and 27. So Okay, and then for our areas, this is going to be consumer surplus. So that's going to be consumer surplus. And then this will be producer surplus. Okay, there's our graph. All the fancy colors. And last, 3 and 4, find the consumer surplus and find the producer surplus. All right. So 3, our CS is going to be the integral from 0 to x bar, which is 240, of d of x, which is 39, minus 0.05x, minus p bar, which is 27, with respect to x. Sure, we can type it in just like that. So let's see, integral from 0 to 240 of 39 minus 0.05x minus 27 dx. And we get 1440. And then 4, producer surplus, the integral from 0 to 240 of p bar, which is 27, minus s of x, which is 15 plus 0.05x dx. And sure, we can type that one in just like that as well. 0 to 240 of 27 minus 15 plus 0.05 x, close, close, dx. And we also get 1440. Okay, well, we have equilibrium, right? So if the producers have a equilibrium quantity of 240 units, and then the equilibrium price is 27, well, this means that at this price and this demand, that consumers will save 1440, and then producers will still gain 1440. So there's the equilibrium. And that's it. Any questions on these notes?